Yeah. Um, we started section 3 of chapter 1 in class today, and I promise that I'm actually going to make a video, okay, to to complete this, and that is the reason why I'm actually making this video. Okay, so we actually want to discuss or record. I started by discussing what I call the process of statistical study. Now, let me put it to you that if I want to carry out statistical study, of course, what are the necessary, um, steps, okay, that I actually need to undertake, okay? Just like what I told you before, we find ourselves in a world, you know, that is stochastic in nature, where different things happens in different days. And you know that I said the appearance of reality, okay, appearance of the real world is independent of human knowledge. So because of that, we actually want to take decision. So how do we take decision in a stochastic environment that we find ourselves? Okay, I said, if we want to take decision in this type of environment, then what we're actually going to do, we need to seek for information. And you know what? Where am I going to get information from? Of course, I need to collect data. Okay. But let me tell you this. When you collect data, information are not readily available. You need to analyze your data using an appropriate statistical methodology. Okay. Before you can have access to the information. Now, if you want to, so if you are collecting data, trying to apply statistical methodology and the like, of course, what you are actually doing, you are carrying out statistical investigation. But you know what? The purpose of meeting now is just for me to be able to show you, to guide you through a process, okay? To guide you through the process of statistical study. Okay. So that is the essence, you know, that is the essence of what I'm trying to do right now. Okay. That's what I'm trying to do. Okay. Guiding you the process. Okay. That is the focus. Okay. So the objective is actually going to be we want to describe the process of a statistical study. Okay. And we want to be able to identify various type of studies as well. Okay. Now, what I'm trying to showcase right now is actually, uh, you know, the particular process that we need to know about if you want to conduct a statistical study. Number one right here means we should actually determine the design of the study. Whatever we want to do, we actually need to plan adequately. Okay. So the necessary machinery that we're actually going to put in place, okay, is what we call, figuring out the design of the study. Of course, the design of the study actually include, of course, you need to state the question that you actually want to study. Then you need to determine the population and variables. Okay. You know, when you start with the question that you want to study, probably you may want to look at the effect of cell phone use, okay, on the risk of getting cancer. Scientifically speaking, um, exposure to the antenna of a cell phone, okay, could lead to risks of getting cancer because the antenna, from your cell phone actually emits electromagnetic radiation. And therefore, the more you place the antenna of your phone close to your ear, of course, the more the risk of exposure to radiation. And because of that, a research was conducted in 2001, okay, in Germany, where they are trying to look at the effect of cell phone use on the risks of getting cancer. Actually, what they did in that research, they used two groups of individuals. The first group are healthy, okay, they didn't have cancer. The second group actually have cancer. Of course, a study was conducted, a questionnaire was drafted and administered to the participants in the two groups, and the question they asked them is, they needed them to indicate the amount of time they spend on cell phone, okay? And at the end of the day, this study conducted in Germany in 2001 actually confirmed that the cancer group use of cell phone more frequently than the control group. Okay, so in that kind of study, of course, we know the question that we actually want to study because we are trying to figure out if there is any connection between the cell phone use and the risk of getting cancer. Okay, so that is the question. And of course, determine the populations and variables. The population here is actually, the population of interest, the location where we actually want to conduct the statistical analysis. They will want to conduct a statistical investigation. And of course, the variables that we talk about this time around is actually, the cell phone use, the amount of time you spend on the cell phone, and of course, the risks of getting cancer. So, which means there are two variables involved. Okay. The first variable is actually the amount you spend on cell phone, which is going to be a predictor variable, which I call independent variable. Then the outcome variable is actually the whether you have the a cancer or not. Okay, so that is the variables in this. Now the third one said determine the sampling method. I told you the other time, if we identify population, we don't carry out 100% enumeration because we don't have time for that. Okay, because of that, we normally take sample. Okay, and of course, I define sample as a subset of a population. Okay. Now, when you want to take sample from a population, of course, we got a sampling method. Okay, which we're going to discuss in this lecture as well. So you need to be able to figure out what sampling technique am I going to use in such a way that whatever sample I choose at the end of the day will be a good representative of the population. Okay, the next step is collect your data. Okay, just go to the population because now you know the variable, you know the population, you know the question you want to answer, of course, and then you know the sampling technique you want to use. Then the next thing is to go to the population and collect your data. You know what? When you go to the population and collect your data, the data is actually massive in nature. Okay, it is not arranged. So what we're actually going to do is to organize your data. Okay, because before you can actually use any statistical method to analyze your data, the data has to be put in an orderly form. Okay, it has to be in good shape. Okay, so organizing your data is like trying to put your data in a good shape before a meaningful statistical analysis is to be conducted. Okay, and after that, we analyze the data, and whatever result we got from the data can be used to answer the question, okay, the reason why we undertake the study. So, like I said, the research conducted in Germany in 2001, where they are trying to look at the effect of, of cell phone use on the risk of getting cancer. The conclusion in that research was that the group, the cancer group of the participant actually spend more time on cell phone. Okay. Another research of that nature was conducted in Great Britain, United Kingdom in 2005, where they conducted the same research using different participants, but the conclusion from the Great Britain in 2005 was that the two groups, they have similar, on average, they spend similar number of time on cell phone. Okay. Now, another study was conducted in the United States of America in 2011, and this was published in American Journal of Medical Association. Of course, what the study in America was not observational study. They actually conducted experimental study where, they assign participants to group. And at the end of the day, their conclusion actually coincided with the conclusion from Germany in 2001 that, the cancer group actually spend more time on cell phone. Okay. So, which means we've really answered the question. Okay. Um, you're actually going to be, in your assignment, you're actually going to be given a practical scenario where they're going to ask you to identify populations and variable. Okay. Now take a look at what I have right now. Neurologists want to study the effect of vitamin C on nerve disorders. Okay. You want to study the effect of vitamin C because vitamin C, people believe that vitamin C is medicinal. It has a medicinal benefit. Okay. So neurologists, okay, they want to study the effect of vitamin C on nerve disorders. And of course, the goal of the study is to see if taking an intravenous dose of vitamin C will reduce the amount of nerve pain reported by patients. That is what they want to do. Okay. They will actually want to figure out the effects of vitamin C. Okay. That's exactly. Can you guys give me 1 second? I actually want to. Okay. Thank you so much. Now, uh, you are asked to identify the population of interest and the variables in the study. Okay. Now, what am I going to do? Okay. And that was why I said, um, since the study seek to determine if a new treatment will reduce nerve pain in patients with nerve disorders, then the population of study will be limited to patients with this specific type of disorders. I want you to take a look at that. The population of interest will not be the generality, but it's actually going to be the population of people with this kind of disorder. Okay? That is the population of interest. Okay? Now, the variable right here is actually vitamin C. Okay? And the pain relief. Okay. Now, there are two variables in this question. Okay. The independent variable, the one we also call the predictor, is actually the amount of vitamin C administered to a patient. And of course, the dependent variable that we call outcome variable is either, you have it's going to be the amount of nerve pain. Okay, we actually want to see whether after taking vitamin C, whether you have a drastic reduction in your nerve pain or not. Okay, so those are the variables of interest that we talk about. Okay, good job. Now, the next thing I want to talk about right now is the process of statistical study. In the process of statistical study, we have what we call the observational study. We have what we call the experimental study. But An observational study, that is a study where uh, researcher merely observe instead of experimenting. Okay, you know, a situation where you conduct a survey. Okay, you conduct a survey, you actually formulate questionnaire. Questionnaire is a pamphlet that have series of questions that are logically formulated, and of course you administer that to the respondent, for information. That's an observational study. Okay, and of course, the experimental study, in experimental study, we don't administer questionnaire, but you know what? The researcher will be the one that we assign the subject, that is this participant, into a group of study. Okay? So the researcher will randomly select, okay, the participant, okay, to group of study, that is to experimental group and to the control group. Okay? Let me tell you that an example of that, the study conducted by Germany in 2001 and the one conducted in the United Kingdom in 2005 were observational study, because in the two study, the researchers actually administered questionnaire. But the one conducted in the United States in 2011 that is published in the American Journal of Medical Association was actually an experimental study, because they did not conduct survey, but what they actually do, they expose, okay, the participants to radiation. Okay, so they actually assign participants to groups. Okay, so the difference between the observational study and the experimental study is just that observational study is very easy to get. When you're talking about it's safe cost. Okay, it's actually safe cost. Okay, when you draft questionnaire and you administer that to people, and you actually want to get their perception about a particular scenario. Okay, but when you look at the experimental study, we spend a lot. Do experimental study, whatever recommendation from experimental study, actually have a strong weight, okay, compared to observational study, because the researcher is the one that assign a subject, the participant to group using the instruction of chance. Now, I'm going to give you another example, to differentiate between an observational study and experimental study. For instance, if you are trying to look at the effect of smoking on the risk of getting cancer, I'm going to say that again. Probably you are looking at the effect of smoking, okay, on the risk of getting cancer. And if you want to carry out an observational study, this is what you're actually going to do. You need to go into a record, okay? Those who have a smoking history, okay? Those who have smoked, probably they smoke for 10 years, okay? They've really smoked for 10 years, okay? Now, what you're actually going to do, if you go to hospital, those who have cancer, okay, you actually want to get their smoking history, okay, whether they've smoked for 10 years or not, okay? Now, that is, if you want to do that, when you are going into a record, okay, to get that, okay, not necessarily assigning, participant to smoke. Of course, you are doing observational study. But you know what? If you want to do experimental study, on the other hand, what you're actually going to do, you need to look for those who have not smoked before. Then you're going to ask them to smoke for several years. And after smoking for several years, you're actually going to measure their lung cavity. Okay? You're going to measure, you're going to have a measure of their lung cavity. Look at that. Okay? You're going to ask them to smoke for 10 years. But you know what? Asking people to smoke for 10 years, that's a lot. There's possibility that some of them could travel to another state, or some of them could even migrate to another country, and some of them could even die. How will you now track, how will you track them? And that is the reason why at times experimental study is very, very expensive. But let me tell you this, aside that, experimental study is preferable to observational study. Okay, now we have an example right here. Now, which type of study will you conduct? An observational study or an experimental or an experiment? Take a look at the question. You want to determine the average age of college students across the nation. Okay? Of course, the study is going to be observational. All what you just need to do is to draft a questionnaire, okay, and ask this student about their age. That's all. That's an observational study. Okay, but take a look at the second one. Researchers wish to determine if flu shots actually help prevent severe cases of the flu. You actually need to go experimental. Okay, you need to go experimental here in the sense that I'm actually going to give you an example right now. Two companies in the world, they've claimed to have developed a success story. They claim to have a success story in developing COVID vaccine. I'm referring to Pfizer, okay, in the United States. Then I'm also referring to Moderna, okay, also in the United States. Okay, and I think there's another company called AstraZeneca in the United Kingdom as well. Now, they've claimed to have developed vaccine, and they claim an efficacy rate of 95%. Now, let me tell you this. How did they arrive at the efficacy rate of 95%? I want to tell you that the company actually conducted clinical trial where they conducted an experimental study where they selected some participants at random, and they fascinated these people with their vaccines. Okay, they vaccinated them with their vaccine, and they exposed them to COVID. What is the game plan? The game plan is that the vaccine, the vaccination they have done will actually prevent these people from catching a COVID, even if they get exposed. So the 95% efficacy rate actually means out of 100% of those that was used in their clinical trial, they actually vaccinated and exposed to the COVID. It is only 95% that was not able to, that was able to prevent COVID. So which means 5% catch COVID even after vaccination. And that is to tell you that, the efficacy of the vaccine is not 100%. Okay? So that's an experimental study. In this kind of situation, you cannot just you can use an observational study. Okay? Okay. Now, I think I've explained that. Okay. And another thing I'm going to tell you is that, one of the advantage of experimental study over observational study, okay, is that, it is used to establish a cause and effect relationship, okay, between the two variables under investigation. Okay, if you take a look at the question now, the flu shot and flu prevention. In the case of the vaccine for COVID, vaccine shots and COVID prevention. Okay, the next thing I want to talk about now, we are under observational studies. In observational studies, of course, we normally conduct survey. In survey, we are going to take a sample of participants from a target population. Now, the question now is, how do we select participants into our cohort, into our study? How do the Pfizer, Moderna, and AstraZeneca that have, that they claim to have developed a COVID vaccine, how do they select, the participant they use in their clinical trial? How do they select that? Okay, since they did not use the entire population. And of course, we going to, to be able to answer that, that depends on the sampling technique that they actually want to use. So I want to start now. What do we mean by sampling technique? The idea is just that since we're going to be choosing sample, okay, we're not going to study the entire population. Of course, we got to use a sampling technique that will ensure that the sample we choose is a very good representative of the population. Okay, and when I say representative sample, okay, the representative sample has the same relevant characteristics as the population. We know when it has a relevant characteristics as a population, it actually represents the population, and it is only when it represents the population that you can actually come out with a generalization. Okay, and does not favor one group from the population over another. So which means there is what we call a principle that, we are using the instruction of chance, no favoritism, no biasedness in the selection. Okay, now I want to walk you through the different kind of sampling techniques that we have. Okay, we got a random sample, we got a simple random sample, we got a stratified sample, we got a cluster sample, we got a systematic sample, and we got a convenience sample. Okay, so these are the type of sampling techniques that can actually be adopted if you want to choose a sample from the population for your study. Okay, taking a sample is just more or less like taking the subset of the population. For instance, if my wife is cooking and I say, okay, baby, can I have a taste of what you are cooking? I don't, I don't necessarily need to eat the whole pot of soup before I'm actually going to have a conclusion about how the food is, the soup is going to taste. Okay. So all what I just need is just going to give me a part. Okay, when it dish a part and I taste it and it tastes good, then I'm going to have a generalization that everything in the pot is actually going to taste good. And you know what? Um, you know, my wife must make sure that she has what I call homogeneous mixture, okay, in such a way, that she has to give equal chance to every item in the pot. So which means every part of the item can be chosen. Okay, if that happens, then it's actually, that part is going to be a good representative of the rest. And let me tell you another reason why we chose sample, okay, instead of study the entire population. If somebody is sick, okay, and this guy visit hospital, okay, the doctor is not going to extract the whole blood in the body before he's going to know what happened to the patient. Well, what doctor is going to do, the doctor is going to take a sample of the blood, okay, not the whole blood or the whole blood. When he extract the whole blood in the which is the population, the population of blood, of course, in the bloodstream of the patient, that could amount to suicidal. That could be suicidal. The patient could die. And that is the reason why we need to be taking sample instead of study the entire population. And you know what? If you want to take sample, of course, you need to be able to understand different kind of sampling techniques we have around. And let me tell you this. These are the different type of sampling techniques we have, what I'm projecting on the screen right now. But you know what? Um, the um, the sampling technique that we're actually going to use depends on the nature of the population. I'm going to write that down. Nature of Okay, it actually depends on the nature of the population. Okay, the population could be homogeneous or heterogeneous. Okay, when I say population being homogeneous, means there is low degree of variability. When I say population is heterogeneous, it means there's a high degree of variability. Okay, now we actually want to revisit this one by one. What do we mean by random sample? A random sample is the one that is used in bingo, the one that is used in lottery. Okay, where every member has equal chance of being selected. Okay, so which means you are assuming this population, the target population, to be homogeneous. Homogeneous means the element in this population, they are more or less the same. Therefore, I can close my eyes and pick whatever. Okay, so when I'm doing that, that's a random sample. Okay, it means I give equal chance, equal probability to all the items. Any item can be chosen. Okay, and that is what we're going to choose is what we call a simple random sample. Okay, every sample from the population has an equal chance of being selected. If I want to carry out a study, okay, maybe I want to study annual average income in the United States of America. If I want to do that, it means my target population will be an American population. Okay, okay, and those who actually have income. Okay, now using the simple random sampling, then our sample approach, it means I'm assuming equal chance to everybody that has income in the United States of America. Okay, or wherever I want to carry out the study. Okay, so simple random sample. So I can only have that assumption if I have the knowledge of the population of interest before I can choose. Okay, before I can apply the simple random sample, then it means, these people that have income, they have to be doing the same work. Okay, they have to be doing the same work. Okay, but you know what? That is not possible. And that is the reason why, if you want to talk about, you want to conduct a research where you want to figure out average annual household income, of course, you got to look beyond simple random sample because, people have different work and they actually get different income. So, which means in that situation, the population is not homogeneous, the population is heterogeneous. Therefore, taking a simple random sample could be misleading. Okay, it's not going to be a good representative. Now, in that situation where there is heterogeneous, okay, where the population of interest is heterogeneous means there is high degree of variability. Okay, taking a random sample will not be a good idea. So what we're actually going to do is to stratify the population. Okay, now take a look at this. Maybe I actually want to carry out a study at the North Central University. Okay, maybe I want to carry out a study among the students. Probably, maybe I want to figure out how much they spend weekly on transportation. Okay, you know what? In the North Central University, of course, we got a freshman, we got a sophomore, we got junior, and we got seniors. Okay, if we use simple random sample, of course, it could be misleading because there's possibility that we're actually going to choose from freshmen. There's possibility we're going to choose for junior. There's possibility we are likely to choose from one group. And when you choose from one group, that is not going to be a good representative of the population. Now, when you take a look at the population right now, since we have freshmen, the sophomore, the junior, and the senior, this is heterogeneous in nature. Therefore, we cannot use a simple random sampling, but we can use a stratify. So stratify means all what we need to do, we need to stratify the population of students in the North Central University into 4 groups. Okay, and that's exactly what I'm showing right now. This is freshman, this is sophomore, this is junior, and this is senior. And of course, maybe I just want to choose 8 people. Okay, So if I want to choose 8 people, take a look at the one in green. Okay, I can decide to choose 2 from freshmen, 2 from sophomore, or from sophomore, 2 from junior, and 2 from senior. Of course, if I now combine the sample together, that is actually going to be a good representative. So what I just defined right now is what we call a stratified sampling. Okay, stratified sampling is actually used, when the population is heterogeneous. Okay, when there is a very high degree of variability. Okay, now the next sampling technique is what we call cluster sample. Of course, uh, for cluster sample, let us assume that the cluster sampling, is a situation where the population is divided into subgroups called clusters, okay? And they are similar to the population, and the whole clusters are chosen at random. Now, this is what I'm trying to say. Maybe probably in the state of Texas, okay? In the state of Texas, you actually, we want to study, want to know the average allowance, okay, the student gets in the state of, the students in the university, okay, students in colleges in the state of Texas, in the United States of America, okay. Now, all what we're going to do, let's say, for instance, we have about, um, let me see, let me count 1, 2, 3, 4, 5, 6, 7. Okay, let's say we have 21 university. I'm just assuming, okay, and the universities are more or less the same. Each of these universities has sophomore, has junior, has senior, and has freshman. Okay, so which means all universities are the same. Okay, now the idea of cluster is that, okay, I can decide to choose 4 universities randomly out of the entire university in the state. Okay, and the 4 university, the one, take a look at this guy now, that one there, of course, that is where I'm actually going to carry out my study. That's a cluster. Okay, now the example I'm showing you here, look at this, is a rice. Maybe I have 21 areas, okay, where we plant rice. Okay, and probably, maybe we want to carry out a research. Maybe we actually want to look at the yield. Okay, maybe we want to carry out research about the yield of rice or something that has to do with rice. Okay, and you know what? If all the 21 region, they look alike, okay, they are similar, then I can decide to choose, 4 out of that or 5 out of that. So since they are similar, okay, I can decide to choose, you know, 4 entities or 5 entities, and that is actually going to be a good representative of the population. So cluster is different from, stratified sampling. Okay, the next sampling technique is what we call the systematic sample. In systematic sample, of course, we apply this to homogeneous population, just like simple random sample. But you know what? Um, the reason why this is called systematic sample is because we are systematic in our selection. Okay, now we can actually have a kind of rule. Okay, take a look at the bottles right here. How many bottles do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, probably 11. Okay, we got 11 bottles right here. And we actually want to choose only 2. And we don't want to use a random selection. We actually want our selection to cut across. What are we going to do? What we actually going to do is that since we have this, the population size is 11, I'm using an uppercase N to represent the population size. And I actually want to choose a sample size of 2. Okay. I actually want to choose a sample size of 2. Okay. Using a systematic sampling, what I'm going to do, I need to obtain a sampling interval K. Okay. Which is going to be the population size divided by the sample size. So in this case, it's actually going to be 11 over 2. And of course, 11 over 2 is actually going to be 5.5. Okay, so 5.5 is actually going to be the sum, Now, if you take a look at my K, it's 5.5, which is sampling interval. Okay, then I need a random start. Okay, I need to have a random start. Okay, I need to have a random start. Okay, the random start will lies between, okay, the random start R will lies between 1 and K. And don't forget, what is my K? My K is 5.5. Okay, I can decide to choose a number between 1 and 5.5 to start with. In this case, we choose 4. 4, and that is the reason why we choose bottle number 4. Take a look at that. Okay, we choose bottle number 4. And every other bottle that you're actually going to be choosing, of course, you're actually going to be adding the sampling interval. Okay, so this is what we mean by systematic sample. So I can decide to be choosing every 4 or every 5 or every 6. Okay, take a look at this. I choose number 4. Okay, I go to this. So this is going to be 4. This is going to be 8. If I'm going to choose another bottle, it's actually going to be 12. You're going to be the one occupy position number 12, because I'm assuming right here my random start is actually going to be 4, and I'm also assuming a sampling interval of 4. Take a look at that. That is the assumption right here. And the idea behind the systematic sample is that, it's actually going to cut across the whole population, and it's actually going to be more representative than simple random sample. Okay, there's another form of sample called convenience sample. I don't know whether, at times researcher selects sample that is convenient to the researcher. A researcher can decide to go to a gas station and meet with anybody there and decide to investigate. That's a convenience sample. Okay, we use convenience sample at times in research. Okay, but you know what? The convenience sample is not random. Okay, it's not random at all. Okay, it could lead to biased results. Okay, but we actually choose convenience sample because we believe, choosing that is more or less convenient to us. Okay, so I just want to tell you, at times somebody could walk up to you and decide to be asking you a question. Okay, so I want to tell you that person is using a convenience sample. Okay, so let us have an example on the sampling technique, because you're actually going to be given, a question, and they're going to ask you to identify, well, what type of sampling techniques, that befits a particular question. Now take a look at this. Identify the type of sampling used in each of the following scenarios. Let's look at question A. It said a pollster survey 50 people in each of senators 12 voting precincts. Okay, 50 people in each of a senator 12 voting precincts. Now I'm going to show you why do we choose a stratify. We choose a stratify because the voting precinct are the strata. Okay, if you take a look at the question again, you're actually going to see that it said um, in each of a senators 12 voting precincts. Okay, precinct right here, the precincts are not the same. Okay, you got 12 voting precinct, and he decided to choose 50-50 in each of the precincts. Okay, if you put all the precincts together, it is heterogeneous. Okay, and that is the reason why he decided to choose from each and every a stratum. Okay, so that is stratified sampling. Okay, the quality control department at a cereal manufacturer measure the weight of every 10 balls of the assembly line, every 10th ball. That's a systematic sampling. Okay, it could be every 10th or every 5 or every 7. Let me tell you, when police is conducting investigation, they can decide to go to a particular highway, and they can decide to start stopping every 10th car. Okay, they don't stop all cars. They can decide to stop every 7th car, like 1, 2, 3, 4, 5, 6, 7. They're going to stop, put that one over, conduct their investigation. Then they're going to count another 7 before they pull. So that's a systematic sampling. Okay. Now take a look at, and that was why B, I said the result is systematic sampling. Okay, because the system of selecting the sample is to choose every 10th. It could be every 7th, every 11th. You got to decide on that. Okay, that's systematic. Okay, so gonna go to see right now a female student walk down the halls in a dorm, asking students how much money they would spend in a food court in the dorm lobby in an effort to persuade the administration to offer such an option. This is actually looking like a convenient sample, because a convenient sample is when somebody just walk up to you, and start investigating you, and start asking question, seeking your indulgence, seeking to know your perception about a particular policy. It could be policy of government. That's a convenient sample. Okay, that's a convenient sample. Okay, and that was why I said this will be a very easy method of surveying for this particular scenario, and it will provide a representative sample of the dorm resident. Okay, then I'm going to go to question D right now. An educator chooses 5 of the school districts in the Chicago area and asks each household in those districts how many school-age children are in home. Take a look at that. An educator chooses 5 of the school districts. This is looking like a cluster, because we assume that all school districts, they have the same structure in terms of in terms of students. I mean, this particular school district has have students that are sophomore, that are junior, and so on like that. So when you decide to choose any 5 school district, that's a cluster, because all the school districts are more or less the same. Okay, and that was the reason why I chose cluster. Take a look at it, because every school, give me 1 second, every school district in Chicago area is a cluster. Now the last one is actually question E, to determine who win $100,000 shopping spree at the mall. The manager draw a name out of a box. Okay, when the manager draw a name out of a box, then that is actually going to be a simple random sampling, because the manager is actually going to assume that everyone in the box, okay, has equal probability of being chosen. Okay, and that was the reason why I actually chose a random sampling. Look at that, because every name in the box has equal chance of being selected. Okay, the next thing that I want to talk about right now, I want to talk about types of observational studies. Okay, observational studies can be divided into what I call a cross-sectional study and a longitudinal study. What do we mean by cross-sectional study? The cross-sectional study is when data are collected at a single point in time. Okay, you collect data from individual at a single point in time. But for longitudinal study, you have a follow-up where you gather data by following a particular group over a period of time. Maybe you collect data from them, you revisit them, you do a follow-up, because you actually want to see whether they have a change of mind. Because we realize that what is permanent in life is change, okay? And then maybe probably their condition, their mentality, their opinion. Maybe you want to see whether their opinion is actually going to change over time. Okay, so I don't know whether some of you have really seen that in the past, whether you have observed that in the past, where somebody come to you to ask a question, maybe they told you they are conducting a study, and they come back again. That's a longitudinal study. But in a situation where they only collect the data at a single point in time, then we call that a cross-sectional study. Okay, now let us now to go into an example of how we can identify a scenario to be a cross-sectional study or longitudinal study. Now let's take a look at this example. Categorize the following studies as either cross-sectional or longitudinal. Let's look at, hey, a group of 220 patients is followed for 15 years. You follow them for 15 years in order to determine the long-term health effect resulting from gastric bypass surgery. Okay? You actually follow them for 15 years. Of course, that should be a longitudinal study. So that was the reason why I chose a longitudinal study, because you follow them for, for more than one time for 15 years. We got some study like that. Okay, so that's an example of a longitudinal study. Now, when you take a look at the second, it said a gastro a gastroenterologist surveys 130 of his patients 6 months after having gastric bypass surgery to determine the average amount of weight loss. Of course, automatically, this is going to be a cross-sectional study. Okay, it's a cross-sectional study because you know uh, it has a specific it collected this data set at a specific point in time. You get what I mean? Here it doesn't go to this patient repeatedly, like more than one time. No, that's a cross-sectional study. And that was why I said in my response, I said, in this study, a snapshot of the amount of weight loss at a specific point in time is gathered. So thus, this is a cross-sectional study. So I just wanted to be able to look at the difference between the cross-sectional study and a longitudinal study. Okay, another type of observational studies we have is what we call a meta-analysis and a case study. What do we mean by meta-analysis? Okay, the meta-analysis is a study that combines information from previous study. Okay, just like when I started the lecture today, I actually told you about a research that I was conducted in 2001 in Germany, the one that was conducted in 2005 in Great Britain, and the one that was conducted in 2011 in the United States of America, that is actually published in the American Journal of Medical Association, where we look at whether they look at the effect of cell phone use on the risks of getting brain cancer. Okay, we could, that's a looking at those studies now, if we really want to compile information from those studies, because those studies have been conducted previously, then we are doing what we call a meta-analysis. Okay, that's what we mean by meta-analysis, trying to revisit what people have done, the study that, a previous study. Okay, more you're going to go, you're actually going to go, you're going to review more than one study. Okay, and that's what we call a meta-analysis. Because why are you reviewing more than one study? Maybe probably you actually want to see whether there's going to be a conflict of interest, the conflict of in terms of conclusion, because the conclusion made by in the study for the 2011 study actually agree with the conclusion of the one in 2001 that was conducted in Germany. Okay, because the one that was conducted in Germany and the United States of America actually coincided. Okay, they agree, the conclusion agree, because they said that people that have cancer, that have brain cancer, spend more time on cell phone. But why they studied in the United Kingdom believe that people that have cancer and people without cancer, on average, they spend the same number of time on phone. Okay, so there's a reason why we conduct what we call a meta-analysis. Okay, probably we want to see whether there's agreement in the conclusion, or across studies. Okay, the next thing is case study. What do you mean by case study? Of course, case study look at multiple variables that affect a single event. Of course, you may want to look at, there's something that we call multiple linear regression in statistics, where you want to look at the effect of more than one variable on the other one. I could remember what I did in my project, my bachelor project that I did in Africa, where I actually look at the effect of the exchange rate, consumer price index, and inflation rate on the gross domestic product of Nigeria. that's a case study. Okay, a case study in the sense that I use multiple variables. I look at the effect of multiple variables. The multiple variables in that situation is the exchange rate, consumer price index, the inflation rate on GDP that we call the gross domestic product. Okay, that's an example of a case study. Okay, now let us now go into an example right now. Categorize the following study as either a meta-analysis or a case study. Okay, now if you actually want to do that, if you want to do that, this is what you're going to do. Now take a look at it. Said oceanographer study research on tsunami dating from 1900 to 2000 to determine their effect on the ocean flow. Look at that, 1900 to 2000. That's so many years. Okay, 1900 to 2000. Right now we're in 2021. So which means we are actually revisiting previous studies. Of course, that was why I choose a meta-analysis. This is a meta-analysis. Okay, it's actually a meta-analysis. Okay, so the second one said meteorologists studied the Indian Ocean tsunami of December 2004 to try to identify warning sign because it's studied for a particular year. Okay, this is a case study. Okay, and that was why I actually choose a case study, because if you want to take a conclusion, then you have, you only considered one period, 1 year, 2004. That's a case study. Okay, that's actually a case study. Okay, now the next thing here is experiment. I just wanted to know, in experiment, we actually have some, terms that we use in experiments. The other time I told you, experiment is when a researcher decide to assign participants to groups. Okay. Of course, in experiment, there's something we call a treatment. Okay, and of course the treatment is actually happens to be condition that is applied to a group of subjects in an experiment. Okay, I'm going to give you an example right now. A COVID vaccine is a treatment. Okay, now you apply COVID vaccine on people, okay, with the motive that these people, I mean, that will prevent them from catching a COVID, even if they are exposed to COVID. Okay, so so in that case, the COVID vaccine is more or less like a treatment, because you're actually going to compare those that are vaccinated with those that are not vaccinated. Let me tell you this: when you want to conduct a research like that, you want to do experimental research, what you're actually going to do, you're going to have two groups. The first group, okay, you're going to give them vaccine. The second group, you are not going to give it anything. Though we used to give them something, we call it placebo. Okay, we call it placebo. Okay, placebo does not have any effect. Okay, it's more or less the same as not giving anything at all. Okay, now let's say we have some individuals, we divided them into two groups. Okay, we give COVID vaccine to one group, and we did not give COVID vaccine to the other group. Okay, we only give them placebo. The other group is going to be used as a control group, while the group that received placebo is an experimental group. At the end of the day, you now expose them to COVID. Okay, you expose them to COVID, and you actually want to compare the probability of getting COVID or of preventing COVID. Let me tell you something. We have some people that were not vaccinated. They did not get COVID. Maybe they are trying to follow the CDC rule of social distancing, wash your hand for 20 seconds and stuff like that. Maybe that is the reason why they were able to prevent COVID. Otherwise, if if there's nothing like that, maybe the whole world we have a COVID without that. So when I talk about treatment, it means a condition that is applied to a group of subjects What do I mean by subject? The subject are the participants, are the people that we're actually going to use for our study. That's what we call subject. Okay, the people that will receive the treatments. Okay, that's what we mean by subjects. And let me tell you, when we say subject, we don't, when we're talking about applying treatment, it is not only for patients. A teacher that is teaching, when teaching students, student is receiving information. Therefore, students are the subjects. Okay, and there's a way we can actually compare students that receive instruction to students that do not receive any instruction. To the instruction that is being passed across, okay, from a professor, we're actually going to refer to that as treatment. Okay, so subject and participants are the same. Okay, now in any research, of course, there's going to be variable, and we got two types of variable, particularly in the case of cause and effect. We have what we call the response variable. Response variable is also called outcome variable. Okay, this guy here is also called outcome variable. We also call it dependent variable. Okay, it's an outcome variable. It's a variable that depends, okay, for its value on another variable. Okay, then we have what we call explanatory variable. The explanatory variable is also called independent variable. It's also called predictor variable. Of course, it is a variable that we manipulate, okay, and we observe its effects on the outcome. Okay, so I just wanted to have that. Now, what are the principles of experimental design? Okay, I told you the other time, when you conduct experimental design, when you conduct experiments, as against conducting survey, because when you conduct survey where you administer questionnaire, that's an observational study that does not have weight compared to recommendation based on observational study does not have weight compared to experimental study. Okay, and why is it that experimental study actually have more weight? Is because we randomize. Okay, because when you randomize, okay, that will enable you, that will remove bias when you randomize. Okay, because you are the one that randomize participant to two different group, in such a way that any of the group, whether control or treatment group, has equal chance of receiving any subject. Okay, then that's number one. Number two, control for outside effects on the response variable. Okay, so so this actually control for outside effect, because one of the disadvantage of observational study is that it could be affected by outside effects. And lastly, replication. Okay, we actually replicate in in experimental design, to have a measure of experimental error. There's always going to be an experimental error. How do we measure that? Because we actually need to measure experimental error if you really want to validate our model. Okay, there is no model. I told you from day one, we're trying to model reality, and the model is not the same thing as reality. There's always going to be an error. Okay, now it is only when we replicate, okay, it is only when we replicate that we can actually have a measure of error. And of course, if you take a look at the COVID, if I want to know whether the COVID vaccine work, then I need to fascinate more than one person. Okay, one person cannot tell me, is not enough. The what is it called? The the outcome of one person cannot be used to justify whether the vaccine is good or not. So therefore, we need to replicate. We need to use more than one person, because when you use more than one person, of course, that will enable you to account for experimental error. And that was why I said replicate the experiment a significant number of times to see meaningful patterns. Okay, you actually want to see, okay, whether the performance of the vaccine on whites, is it the same as on the people of color, stuff like that. Okay, Now, um, I mentioned what I call a control group the other time and a treatment group. Of course, the control group is a group that receive no treatment. Okay, they're only going to receive placebo. Okay, they are being used as a point of reference. Okay, they receive nothing. Okay, now the treatment group is the one, is a group that actually receive treatment. Okay, and you know what? In clinical trial, we actually want to compare the two groups. Okay, we want to see whether the treatment that we have introduced, whether it performed better than nothing. Okay, because if there is no significant difference between the effect of the treatment and nothing, why do we need to worry ourselves? Why do we need to waste resources? Okay, so in a situation whereby there's a significant difference between the performance of the treatment group compared to the control group, of course, we have justified introducing treatment. Now, the next thing is what we call confounding variable. What do we mean by confounding variable? The confounding variable are factors other than the treatment that cause an effect on the subject of an experiment. Let me tell you this. If you are trying to look at the salary of workers, okay, we're trying to look at the average wage of workers, okay. If you are looking at the effects of maybe effect of gender, okay, on on the wages, okay. If there exists another potential factor that could have effect on wages, another potential factor like years of experience. If you don't, if years of experience is is significant, okay, to wages, and you don't consider years of experience, okay, then that's a confounding variable, okay. You know, if you have a variable that actually affects, okay, that have effect on the subject, of course, that we're considering, and other than, that have effect on the subject, other than the factor you are considering, of course, you're actually going to have a misleading result. It means you confounded highly significant factor, a factor that you are supposed to adjust, a factor that is supposed to include in the model. That's what we mean by confounding variable. Okay. There is something we call a placebo effect. Of course, I told you a placebo is a substance that appears identical to actual treatment but contain no intrinsic beneficial elements. Okay, it doesn't have any effect at all. It's being used as a control. But you know what? We are not going to tell the participants that they are giving placebo. The participant will have the knowledge. What they're going to have in mind is that you are actually giving them treatments. Okay. Now, uh, there's something that we call a single blind in experiment, and there's something that we call a double blind. Okay, a single blind is when you don't tell the participants that they are giving placebo. Okay, you don't tell them, because if you tell them they are being given placebo, they're actually going to lose hope. They are not likely to participate. Okay, that's what we mean by single blind. Okay, single blind means it is only participant that is not aware of what is going on, but the researcher is aware of that. But when we talk about double blind, the double blind means both participants and the researchers, of course, they don't really know a particular patient or a particular subject that receive what is it called, the placebo or not. And that was why I said in a single blind, I said the subject do not know if they are in control group or in the treatment group. But in the double blind, okay, neither the subject nor the people interacting with the subject know to which group each subject belong. Okay, we use this in research. Okay, so which means it could be single blind or double blind. Okay, we're going to go into an example right now. Give me 1 second. Okay, we are very close to the end of the lecture. Now, we want to go into an example right now. Consider the study from example 1.11 in which neurologists want to determine if taking an intravenous dose of vitamin C will reduce the amount of nerve pain reported by patients. Suppose that the study was narrowed to focus only on patients with a nerve disorder, multiple sclerosis. After study approval, the neurologist solicits volunteers who are patients with MS who are reporting nerve pain. The participants are then randomly assigned to two groups, which means we're doing experimental study, right? Each having 20 participants, okay? Of course, in this group, you got 20 participants. In the other group, you got 20 participants. This is a control group, and this is a experimental group, okay? Or the one we also call the treatment group, okay? We also call that the treatment group. Okay, now take a look at that. Now, participants in group A, okay, you have two groups, are administered intravenous dose of vitamin C. It means participants in group A, you give them vitamin C, okay? But the participants in group B, you did not give them vitamin C, you give them placebo. It means you give them nothing. It means you are comparing effect of vitamin C with nothing. Okay, if I use vitamin C, if I have enough pain, if I use vitamin C am I going to have a drastic reduction in pain compared to even if I don't use vitamin C at all? Okay, now, um and their pain levels are also tracked. The patient are not told which of the two groups they are in. Okay. We did not tell, the researcher did not tell the participant, the people they use in this study, the particular group they are into. Okay. Now, however, the nurses administering the IVS are aware of the group assignment. Okay, which means the researchers, the nurses, they are aware of the group assignment, but you know what? The participants are not aware of that. Okay, and after a predetermined length of time, the amount of pain reported by the separate groups are compared to determine if an intravenous dose of vitamin C will reduce the amount of nerve pain. Now the question now is, identify the explanatory and response variable. What is the treatment? Which group is the treatment group and which group is the control group? What is the purpose of administering saline to group B? Is this a single blind or double blind? Do you think this is the best choice for the study? Okay. And of course, I think I put the answer to the question right here. You can check the slide. Of course, based on what I've explained before, of course, you can track that out. Okay. Lastly, for today, I'm going to talk about institutional review board. If you are carrying out statistical research, particularly something that has to do with life, okay? We have what we call an institutional review board. And of course, the institutional review board is a group of people who review the design of a study to make sure that it is appropriate and that no unnecessary harm will come to the subject involved. I want to believe before the Pfizer and Moderna will conduct their clinical trial using human beings. Take a look at this. It's, if this organization call you, okay, you know what? We actually want to vaccinate you with our vaccine, and we're going to expose you to COVID. Okay, that has to be, you need it, that has to, a particular, organization that I call institutional review board. You need to, assure that that will not cause harm to the patient. I mean, will not cause harm to the person you are using for the study, the participant you are using for the study. Okay, so we have this board around that will ensure, okay, that will review the design of your study and to make sure that it is appropriate and that no unnecessary harm will come to the subject involved. That's what we mean by institutional review board. Another one is what we call informed consent. What do we mean by that? That actually involve completely disclosing to participant the goal and the procedure involved in the study and obtaining their agreement to participate. Okay, you actually want to use them. You need to be able to seek their consent that this is what you want to do. This is your goal. They need to be aware that and when they are aware of that, of course, they need it's either they agree or not. You can't force them, and that's what we mean by informed consent. Okay, this is where I'm actually going to stop today. Of course, I actually need you to watch this video. This will go a long way in, you know, knowing how to figure out the assignment. Okay, and if you have any question, okay, that you actually want to ask me, if you need clarification, of course, you can actually meet with me during my office hour. Okay, I want to appreciate everyone that will be watching the video. And until next time that we meet again for another exciting topic in statistics, you make sure you stay safe and have a good day. So bye for now, guys.